Wow, that was really loud. Okay, once again, so this would be the lesson right after solving, problems with algebra, with your geometry shapes and stuff. Solving simple equation. An equation is a statement that two expressions are equal. So it's not an expression. It's not just a sentence. An equation always involves an equal sign between the left side and the right side. Some examples, hey, left side equals right side. Left side equals right side. Left side equals right side. And left side equals right side. And that part's really important because if you decide to add something here, add a 3, then because it's equal, you have to add a 3 there. If you decide to multiply one side by a 10, then because it's equal, the other side has to multiply by a 10. If you give the left side a cookie, then because it's equal, you have to give the right side a cookie. You get the point? I hope so. And here's where the mathematics comes in. If you want to solve an equation, in other words, if you want to figure out what the unknown variable is, we reorganize it so that the variable is alone. You remember me saying that, I hope. I've said it a lot of times throughout the entire unit, but here's the official lesson on it. Yes, Miles? Yeah, go quickly. Okay. This reorganizing so that the variable is alone, the official word for it is called isolate, isolation, or grammatically correct. This is called isolating the variable. When we move something across the equal sign, we perform the inverse operation. So let's get these blanks out of the way first, okay? So I think isolating makes sense, particularly for me, just because I'm somehow affiliated with the team. Even with basketball, there is ISO plays, right? Kobe Bryant, may he rest in peace, probably one of the greatest ones. James Harden, another one. People who are sort of like all-stars of the particular team are set. The entire team moves away from the court, forcing a 1-versus-1 sort of street ball style play. Isolate, okay? There's a lot of plays like that in sports. Well, it sort of applies for mathematics as well. We simply use the same English word. We're trying to get the variable all alone. Isolation. So how do we do that? Well, you're gonna see us doing the inverse operation quite often. If you see something is being added, the inverse is subtraction. If you see something being subtracted, the inverse is addition. If you see something being multiplied, the inverse is division. And for division, it's multiplication. Simple enough to say, right? Without even any knowledge of mathematics, you can probably guess these things. Let's see it in action. This is important. Here we go. Let's go all the way down. First example, isolate by subtracting. What do I mean? Well, take a look at the equation. Look at the left side and the right side. First off, where is the x? Left or right? Left. And then, Finn, what is happening to the x right now?
It's being added to 4, so to isolate we have to subtract 4 from that side.
Right. No, there you go. We need to turn that into what I'm going to call a zero pair, right? Just because we talked about this in the previous lesson. If you want to, I'm going to show all the steps right now, okay? If you want to get rid of a +4, you need to subtract by 4. But if you do something to one side, you can't just leave it alone on one side. You must also do it to the other side. All right, on the left side, +4 minus 4, it equals a 0. So I'm not going to write it. Why bother wasting my time writing +0? 6 minus 4, that's a 2. Ta-da! We got it. Now, I know you're saying, well, of course it's a 2, because something plus a 4 equals a 6. It's got to be a 2. I get it. But as we progress, you're going to get more and more complex equations where you won't be able to sort of guess the number using your number sense. That's why I'm forcing you to go through all of these steps one by one. Number 2. Actually, we'll skip number 2. Number 3. A plus 2 minus 10. Yes? Sorry, I can't hear. I see. Right. So there are a lot of people, even teachers, will say, well, you see the plus 4, just bring it to the other side. But surprise, it changes signs. I get what you're doing, but when we get to multiplication, for example, if you 2x equals 4, when you bring it to the other side, a lot of people start doing, for example, this. You're like, okay, I have to divide, but I'm going to the other side, so it must be a negative. Like, they start to confuse things. I just want to avoid that. So I'm going to be as straightforward, as regimented as possible. And yeah, whatever you see, do the opposite to both sides, and you'll never make a careless mistake. Okay, that's the next one. A plus 2. The goal is to isolate the variable. So I want A all alone. How do I get rid of that thing? Yep. Yeah. Subtract the left side by 2, which means I subtract the right side by 2. That portion becomes a 0. This part becomes negative 12. There it is. Number 5. This time the variable is on the right side, but that doesn't mean I change my thought process. I still want to get R all alone. How do I get rid of plus 2? John? Yeah, what's the opposite of a plus? Yeah, that's it. So it's a plus 2, so I'm going to subtract both sides by minus 2, which will get rid of this part. It leaves this part. It makes this part go away, which means all I'm left with is the R. So what is negative 8 minus 2? R is going to be negative 10. Every single time you're looking at what you need to do to get the variable all alone. Isolate the variable. Before I ask if there are any questions, I'm going to do an example of every single one. How about I do 2 examples from every section in hopes that you sort of get the hang of it. If you still have questions, that's fine. Please ask me. But I am going to give some class time to do it. Yep. Okay. This time I need to isolate by adding. You will see all the variables are being subtracted. So hint, hint, how do you get rid of a subtraction of 2? Yeah, there you go. I'm going to, so this time I'm going to show all the work this time. I have a minus 2. I'm going to add by 2. And on the right side, I have to do the exact same thing. When you do so, V equals a positive 8. 6 plus 2, right? How about we do number 6? H minus 5. Kareem, you with me? Okay. How do you get H all alone?
Plus 5 for 5.
Yep.
Plus 5.
Yeah. Good. So plus 5, that's nothing. Negative 16 plus a 5, that's your integers, negative 11. Done. Every single time. Every single time. The same can be done with multiplication and division. isolate by dividing. Okay, this time, forget the plus and minus. Right now, this is a 2 times x. The opposite of multiplication, division. Divide by 2, divide by 2. Why does this work? Well, 2 divided by itself, this is going to simplify into a 1, leaving me with 1 times x, or just x. On the right side, 6 divided by the same 2, x equals a 3. Okay, same idea. Let's jump to number 6. I have 6 times a. I want a all alone. Andrew, with me? Andrew, you with me? Yep, go for it. I want a all alone. How do I get rid of a multiplication? Same thing here. Divide by 6, divide by 6. The 6 divided by 6, this is going to simplify into a 1, leaving the left side as just 1a. 1 times a is just a. Negative 18 is dividing by that same number, a 6, leaving me with negative 3. A is a negative 3. Last, oh, I did. Negative 18 divided by 6. It is because in the very near future, it won't be so simple. It's going to be multiple steps. You will see. Yeah, you will see soon. So right now, it might seem like that's such a extra step I have to take. I like to think about it this way. I want to ask you to try it this way. First, it might save you a lot of hassle in the future. Okay, last one. Isolate by multiplying. It's clear. First one, right now, this is the same. On the left side is the variable. And this is the same as saying x divided by a 2. But it's a lot better just thinking about it as x divided by 2 here. I have x dividing by a 2. How do you get rid of a division? What's the inverse? Yeah, 2 times 2. And you gotta do the same thing on both sides. Division of 2, multiplication of 2, they actually simplify into a 1, leaving me x equals 10. But I hope you see that the same logic, the same idea is being applied. Do whatever is the inverse, the flip. Okay. Let's do number 6. Right now we have subtraction of, or negative w over 9. So w divided by 9, negative w divided by 9. I don't like that division of 9. So let's multiply it by 9. So we have division of 9, multiplication of 9. This will simplify into a 1. So now I only have negative w, and this is negative 90. Ooh. W is not actually alone right now. It's a negative w. So how do I get this negative 1 multiplying to w out of the way? Key word. How do I get rid of a multiplication of a negative 1? What's the opposite? Yeah. What's the opposite of multiplication? Yeah. So you will divide both sides by a negative 1. That's opposite of multiplication. And so this turns into just a 1 this becomes positive 90. Positive W is equal to positive 90. That's as far as we're going to go today. You cannot run before you walk. Okay? And so I need everyone to really be comfortable with the single step algebra, be able to look at something and know exactly what to do without even thinking. Just be like, yeah. Pardon? No, it equals a positive. From our calculations, we showed that negative W is equal to negative 90. I don't like that W there, so I decided to get rid of it by doing the inverse. What is the inverse of a negative 1 multiplying with a W? Well, the inverse is going to be a division of negative 1. And so I did both. So it became W equals positive 90. Okay, again, please practice this. Do as many of these questions. You know what? I'm going to say do them all. All of these questions are single steps. And so the practice section only has 9 that you need to do. Do the entire booklet except for the last 2 sides. So in other words, do until the front of page 2. So basically up to here. Let me do this right now. Up to that portion right there. Homework. Oh geez. Homework. Do up to until end of page 2 front. Does that make sense? Should I just call it page 3? I don't know. Front page 2. Finished front of page 2. Okay. Yeah, go quickly. Can you find slow and then bring it back? Any questions?